Hello and welcome everybody. We are going to give it just a few more seconds and get started. I think it's about 10 a.m. Pacific right now. So good morning, good afternoon, and good evening, depending on where you are joining from. We had over 1,000 people registered, close to 1,100 actually, for this class. So there is a lot of interest. We are expecting several hundred of you to join from all over the world. Kubernetes Master Class Series is something new that we started just a few weeks ago. I think this is session number 3. Each class is about an hour long. We give about 20 minutes or so for Q&A. If it goes over, we are happy to stay back. We cover a variety of topics. We have covered many, or 2 or 3 so far, building an enterprise Kubernetes strategy. And today we are actually doing getting your hands dirty in the container sandbox. A very interesting topic, lot of things happening in this, and we have a star speaker for this session. But before I go there, let me just talk a little bit about some of the topics that we will also cover, which are up and coming. So up and running with Windows Server containers, that's coming up. Preventive security with Kubernetes, again with our friends from security industry, that's coming up. How to build cloud native CI/CD pipelines. I'm sure it'll be interesting for many of you. So tune in. If you want to know the entire series and you want to access some of the past ones that we have done, here is the link. We record every one of these. If you are just starting out on Kubernetes and you just want to learn, tell me a little bit of fundamentals of Kubernetes and how to make it simpler, and something about Rancher. We get a lot of questions about what is Rancher. Then there is another thing that you can do. Every Thursday we run this training, rancher.com/training. You can go and try it out. We run it every Thursday. We have a very powerful, very insightful speaker for this. And they do a demo. They basically get you started with Kubernetes, and you are on your way. So think about joining this class. It's really good if you're just starting out. All right, before I get into our speakers, let me quickly talk about why we do this series. So the reason we do that is because we talk to thousands of users every month. We go to DockerCon, KubeCon, and we hear a lot of common questions about how to solve different challenges in Kubernetes. And these challenges could be how to manage multiple clusters, how to bring up a cluster more easily, how to deal with security, how to deal with CI/CD, how to monitor workloads, and many more. So we basically thought what to do, and we have an open Slack channel where people communicate with each other. We found that there are tons of resources on Kubernetes, and typically everything is free, and it's useful. It's useful if you know where to go and how to find it. So we started this series. We thought we'll pick a topic at a time and just address that one topic, and you guys are on your way right away. So we do almost no marketing here. We try to just deliver the content as quickly as possible so that you get what you want and you can move on. But before we get into the content quickly, here are the speakers. We have Ariel Schuper, who's Senior Director of Product Management at AquaSec. AquaSec is a security company. If you haven't checked them out, please do. Ariel has more than a decade of experience in cloud and security products. And he was an entrepreneur, product management, marketing. He has done it all. He's based in Israel. He used to lead cloud security strategy and products at Checkpoint. So if you're looking for someone who can really talk to you in depth about container security, Ariel is your guy. Definitely, you are at the right place. My name is Ankur Agarwal. I'm head of product management here at Rancher Labs. My job is typically to build new capabilities, work with partners like Ariel, find out what works for our customers. We basically deliver an easy way for you to build Kubernetes, multi-cluster Kubernetes, and then manage it. So I'm not going to talk a whole lot about that. Let's just get started. Today's rules, we can run over. We do welcome questions. You can ask us anything. We will try to answer as many of those questions as possible. We get hundreds, but we try to answer as many as possible, and we are happy to stay back if you are willing to stay back. There are no bad questions. So we have seen everything. People asking us, how should I talk about Kubernetes to my management, to anything that you can imagine. Like, so there are no bad questions. Feel free to ask us. Session is being recorded. We will upload it and you will get a link to in your email as well. Okay, so with that, I'm going to stop and we will get right into the content. So Ariel, I'm going to hand it over to you. Please go ahead.
Thank you very much. Hi, everyone. Hello, everyone, and good morning. I'm just going to share my presentation. Okay, can you make me a presenter?
I can definitely do
Otherwise, I
that.
need to sort out between all the hundreds of attendees. So, everyone, good morning, good afternoon. My name is Ariel. Great. And sure. Okay, now we can all see my screen. Great. All right. Sorry for that. Okay. Yes. So now we can start. So I'm going to talk about container sandboxing. I think those of you who read the news, the headlines last week with the new CVE, which was discovered in Runcie, can come to my mind that this is probably a practical example where a sandboxing container could help or prevent these threats, for example. And my talk today, I'm going to talk about the different sandboxing technology and what is sandboxing in general. What are the threats that we need to face? What do we solve with it? And we go on different technologies which were, I would say, discovered or were announced in the past year related to sandboxing technology. Let's first start with what the sandboxing context in the security. So in the security space, sandboxing was a revolution. It represented, a paradigm shift from, reactive security to proactive security. Now, what do I mean? In a classical security environment, in the days of the EDRs, the antivirus, or the firewall network, or the intrusion prevention, all those systems were called or considered reactive. You need to have the vulnerability to be discovered, the exploit to be known, and then you can create a patch, you can create a signature, update quickly your devices, and from there on you are protected. But the first victims, those who were impacted from the 0-day didn't have any solution, and those are always were the first victim that had to be sacrificed. Now, you might think about, what the big damage, but if you recall about 2-3 years ago, there was a ransomware attacks out of, malicious activity to encrypt your disk, encrypt your environment, and demand ransom to open it. And they found different methods to spread it very quickly and very efficiently. So under no doubt, this was kind of a gap in the security environment. And when first sandboxing introduced, and it was a FireEye introduced the concept of taking any suspicious file, any suspicious behavior, bring it in a secure environment, monitor it, and then identify if it's trying to do something malicious. Even if you're not aware of it, you don't know it, you don't have any signature for it, you can really detect how it behaves and then determine very quickly if it's a malicious traffic or malicious payload that you want to eliminate, or it's something benign which you can pass on. So there was a real revolution. It was very nice, and I think it's really speed up or brought up the security back to be effective with it. Now, when we first heard about container sandboxing, I was like very happy, and I thought there was really a nice way to secure and to prevent and to find all those unknown and 0 days, and it can really create a secure environment for all the containerized application. The reality was a little bit different, and this is the reason why I thought it might be interesting to get more details and more information about what is a container sandboxing, what does it do, how does it protect us, and when and or when not it's recommended to use it. So that's going to be the topic of my session today. Before we dive into the details, let's first start with trying to understand, what is the containerized application threat landscape? What do we need to protect from? what are the different attacks which are possible in containers, what's new that we need to do, and then we can, understand where the sandboxing technologies fit in and where we can leverage them and for what. So in order to get kind of, an interesting baseline, I look a year back, and looking back a year, trying to bringing the interesting attacks or the interesting vulnerabilities which were discovered. So we started the year, with simple thing like the Tesla crypto hijacking attack, and this was an attack which, someone left the Kubernetes console unprotected, open. Malicious users found it. Yeah, I would say different users found it. It was open. They poked inside. They found some credentials to AWS account. They went into the AWS account. Again, it was not secure. There they found an S3 bucket with all the different credentials, and then they were managed to bring up a full Kubernetes cluster, which everything it did was crypto mining cryptocurrency. They made it in a smart way, which was kind of hard to discover. The CPU load was not maximized. They were running only 30-40% CPU load, and they didn't use all the famous known mining site. They were using a proxy, and the proxy was communicating with the site. So they did a smart way, but the attack was very simple. Someone just forgot to secure or put a password and logging information on the Kubernetes console. So this was a kind of famous attack on Kubernetes, but nothing new or special, right? And then just a month later, there was an analysis of Kubelet, the Kubelet API that were kind of allowing allowing an unauthorized access, which again was found in one of the Kubernetes clusters to lead to crypto mining functionality or crypto mining malware that was spreading around. Another interesting thing came from Juniper. The credit goes to Juniper Labs. Found APIs which exposed and allow containers to exploit them, and then again download a crypto mining and spread around all the different nodes on the cluster. So all those attacks were pretty much simple. They were just using something, a different API or an unprotected API. They're using a new front, but the attacks were simple. Then towards beginning of December, just before KubeCon, there was already a significant flaw. Now there was found the Kubernetes API gateway, which allow complete, privilege escalation and complete takeover of clusters. So if until now we're doing some kind of a crypto mining, maybe it was not nice, but not something bad. It could be like, it was not like something terrible, but taking control over the cluster, taking full control, this is something which already has substantial sequences. So this is something which already becoming more scary. And then just last week, just a minute. Then just last week, there was the last CVE which was discovered, and this was a RunC vulnerability that allow, if someone managed to leverage it, allow him to get root access on the host, and then can do anything which he wants with this. Also, this is something which already becoming much more significant, because here the potential loss, the potential of the attack is much more significant than just crypto mining. Crypto mining is not convenient, but in the worst case, you lost some CPU power, electricity. By taking over the host or running your Kubernetes cluster, this is something which is more significant. Now, when you analyze the different attacks, so that we saw, you see usually the attacks are not new. Pretty much the same attacks. What's new is either the environment. Okay, there are exposed ports, no authentication, privilege escalation, but most of the attacks are pretty much leveraging classic tools, just have more fronts, so new things to attack. And this is why probably we need to expand it beyond the classical tools or beyond the classical environment, because the attacks are the same, just the environment is slightly different, and you need to adapt it to address the new environment or to watch the new fronts, new APIs, and new connectivity capabilities. But when you poke into the attack themselves, they were nothing dramatic different or changed. Now this bring us to discuss, how would an holistic container security look like if we were design a complete security from all the different potential attacks? How's it going to look like? And the first important thing is we need to add controls which minimize the attack surface. Okay, things like vulnerability scanning, on sensitive data removal, or encryption that the area from where someone can attack your container. Then the next stage would be to minimize the attack potential. So we're trying to minimize the path that an attacker can take, but eventually we'll find something. Then our goal is to minimize the potential of this attack, to minimize the landscape as much as we can, that even if you manage to attack or to get control, the capability will be very limited. So this is the area where least privileges play a big role, authentication, authorization, role-based access control technologies play the biggest role in those areas. And then the second stage, or maybe the side step from this one, is how we can minimize not just the attack potential on the actual target, but how we can minimize the blast radius, meaning assuming, okay, we have a target, the target was captured, but now how we can prevent the attackers from leveraging it and moving it in a lateral movement, or moving to other targets, or trying to gain more access or more targets in his infection or in his data exposure. And this is where the sandboxing really fell into place, because what sandboxing is doing is trying to isolate the container in a way that if someone managed to attack the container, it will not be able to get access to the operating system, to the host, and then of course break out and see other containers as well. So this is the scope of where the sandboxing come. Obviously, when you want to plan your security, you need to make sure that your containers cannot be attacked, or at least try to eliminate all the classical way to attack it, and then of course try to minimize what the potential of this attack can do to the container itself, and then of course take care of the propagation and how you can prevent the lateral or how you prevent the attack from propagating to other targets in your environment. So it's important to understand what's the context of this sandboxing. So it's pretty much to make sure you cannot break out from the container. So meaning it does not protect the container itself could be breached, but it makes sure that you will not be able to reach the underlying operating system or the host, or get exposed to other containers which share the same physical host. So there would be a security guideline for containers. Now, let's take a look at the sandboxing, and let's try to get more details on how we isolate things regarding the container and why we want to use sandboxing. So now we all know that containers share the same, share the operating system. They share the same kernel. It's great for development, deployments, but as vulnerability, and they can allow you to break out the container. Pretty much, it's the goal that all the sandboxing technology is trying to do, is to isolate the container while providing it the needed kernel functionality. So we can feel in an isolated environment, we can operate in an isolated environment, you get all the resources you need, to get all whatever you demand from the operating system. However, you cannot really access it, or your access is really, really very, very minimized. So you won't be able to effectively leverage any exploit or 0 days to break out and get exposure to anything else which run on this node. Now, the question is, why do we need sandboxing if the Linux kernel has great isolation tools? So things like SECComp, which allow you to create whitelist or blend of all the system called profiling and allow you to create a profile that is whitelisted and eliminate or prevent any other system calls. SELinux, which allow you to get a very fine-grained role-based access or role-based access control. UpArmor, which is another way to restrict your system calls from the container to the kernel. We have all those technologies, and the question is, if all those technologies works and we're using them for many years, why do we need the sandboxing? Now, I don't know how many of you has experience with those isolation technologies in the kernel or using it on a daily basis and defining a list of permissible system calls with Seccomp or with UpArmor. I don't know how many of you using SELinux in production, which might be challenging. But the reality is that it's quite tough, right? It's not so easy to manage. It's very hard to debug. Take a look, for example, at a Seccomp profile. This is something that we create in Aqua. We allow our users to create a Seccomp profile. We kind of correlate, multiple executions of a container, list all the different system calls, and then prevent any other system calls. Now, the challenge working, with AppSecOm, it's like so hard to understand if there is if something is rejected and consequently, this process is killed. Why is it killed? Who killed it? It's very hard to manage and list it if you try to create long records that try to simulate multiple tasks or different executions. The day-to-day operation of those technologies are quite challenging. It's interesting, SELinux, the iteration process and the restrictive mode can really become a real threat. I know that a lot of system administrators completely remove or don't use it just because they're afraid from this lock-in potential. And then UpArmor, I found an interesting, funny GitHub project called Bane by Jess Frizzell. Those who know whether she said, that she called it, Bane because the AppArmor profile generator, because anytime someone asks her for an AppArmor profile, creating it by hand, could be the bane of her existence, right? So it really emphasized all the different challenges, of using those isolation technologies. They're not very friendly. They're quite hard. They're very effective, but the daily operation makes it challenging to use. So that's probably the reason why we started with sandboxing. Very intuitive, very simple, very easy to use, and really doesn't require to bring in a staff of few security architects that will constantly try to profile different allowed or disallowed system calls. And this is where containers or sandboxing technologies started. Now, the first one, we'll start to go into the details of each of those technologies. Feel free to ask questions if you have or you want to get more details before we dive in. The first project for the sandboxing technology was called Katacontainers. So those of you familiar with Katacontainers, it's running under the Open Networking Foundation. It's part of the project, and its main purpose was the first and I think probably the most mature sandboxing technology. Now, the path that Katacontainer chose to take was to create a lightweighted hardware virtualization, what they call the QEMU Lite. So they use the QEMU technology and created, literally hardware virtualization, but instead of spinning up a virtual machine, they spin up a container inside this virtual machine. So what you can see that each container or a pod is booted like a VM, has a complete isolation, its own unique kernel. There's no access to the host. Now, the interesting thing they did, and that's what makes it very popular, is creating an OCI compatible runtime called the Kata runtime, which really allow it to run as a regular container. So it can intercept any runtime command. It has an agent inside, the virtual machine, which communicate with the shim or communicate, with the different runtime. And then from one side, the agent can communicate I/O needs or I/O communication or storage requirement. On the other side, it can intercept any call and translate it or execute it inside this VM on the container itself. So the beauty of it is it's really handy. It's nice to use, taking the hardware virtualization concept and separating the host into different lightweight VM. They made a lot of effort to optimize performance, a lot of reduction of code, removal of unnecessary items, a lot of work. They spent a lot of work on optimizing the performance and made a very nice work to create a nice operative container or VM-like for containers. So the architecture is very nice, and it's probably the most mature project. We'll talk about its operation in a minute, but let's talk about the security aspects. Now, Katacontainer use the virtualization technology, which is based on the QEMU. They used as a base and created the QEMU lightweight or the light virtualization. Now, the challenge is that if you look at the QEMU, and this is what kind of struck me, it was the first thing that kind of happened to me when we started testing it, is an email which I saw on the Katacontainer development list and asking whether or not we checked the security issues. And the answer was no, we didn't secure it. And I said, okay, so let me try to see if using it, it's secure or not. So as a disclaimer, I didn't try to break out of Katacontainer, but I just made a small investigation on the QEMU, which is the base of this technology. Now, the QEMU happened to be, if you look in the past year and a half, has a lot of severe vulnerabilities. So as you can see in this list, I prepared it in December, but has, quite a few of super high vulnerabilities, which are in a critical level, right? Grade, which is 9 or 10, it's in a critical level. Just for example, those of you who heard last week the runC vulnerability that allowed to get root access on the host, it's the threat level was 7.2 or 7.3 if I'm not mistaken. Here you can see just in 2018 and 2017 some super significant critical vulnerabilities, which kind of highlight the QEMU as not the most secure technology, even if you strip it for many of its items. Going a little bit more further into the details or digging into some more news, you can see that Google stopped using QEMU as under their KVM virtualization or hypervisor to improve the security of their cloud. You can see that Palo Alto discovers some new QEMU vulnerabilities. So if you just dig into QEMU more in there, you can find that it's not the most secure. Now, I had a chat with the Katacontainer team, and we discussed it, and they made a lot of optimization and improvements, and many of those items which are the underlying for those vulnerabilities are not items which are covered in the QEMU Lite. But again, nevertheless, we need to pay attention that this technology might suffer from some substantial challenges, even though most of them probably were handled or removed by the team. Now, the second technology, which was introduced somewhere towards the middle of the year, around May timeframe, was gVisor. So gVisor was an initiative by Google, which created a very nice or completely different solution to isolate containers. And what they did is creating a user space kernel. So what happened now, your container does not communicate with the host or with the operating system, the kernel of the host. It communicates with a dedicated user kernel which run user space, right? And then this user space kernel communicate with the host kernel if needed in a very limited manner, right? So we can really limit the host kernel accessible surface. The application get anything it needed or anything it expects from this kernel. The gVisor intercept all the system calls and act as a guest kernel for each container. And then only on the very few items that this kernel needs, it can go through gopher, which then gopher communicate with the kernel for storage or for specific IO demand things. But this is in essence a completely new approach to isolate containers, just kind of create an substance or a substitute to the host kernel. So that's super interesting. And of course, what makes it very nice, the fact that gVisor has also an OCI compatible runtime called runsc. It's integrated with Docker, can also run in Kubernetes, and it makes the operation of those sandboxing very easy and very intuitive for Kubernetes environment. Now, when you're looking into this technology, again, looking at the security aspect of this technology, then you're very impressed by the ambitious approach that Google took with a gVisor in creating a new user space kernel. Now, a lot of things which were solved over the time in the regular kernel need to be addressed in this kernel as well. So no surprise, I was really surprised that just a few months afterwards, a researcher which worked in Google itself found a way to break out of gVisor and leverage the file system cache in order to do so. So this, of course, was fixed. And then just another month later, another privilege escalation in gVisor, another researcher who found a way to do some privilege escalation and to escape from the container and get root access on the host. And again, and I think that the bottom line is it was not a little bit surprised because the kernel is a super complicated piece. It was developed for many years, and trying to create it from scratch, obviously, or there is a big potential to find some of those previously known or detected mechanisms that were already addressed and patched in Kubernetes in the kernel, but were still need to be worked out in this new project. Another interesting approach was just 2 months later, around July timeframe, and that's where IBM announced the Nabla Container or the Nabla architecture. And the Nabla was, again, a completely new approach to isolate container. I would say even quite unique. It used the unikernel architecture, the libOS, based on the Solo 5 project, and this new, operating system or this new unikernel pretty much avoid any system call. It has hypercalls, right? But again, it minimized the potential attack surface to only 7 system calls, right? And this is based on Seccomp. They created an underneath Seccomp environment which you only allow 7 system calls. Everything else is supplied by the unikernel. Using the onprem unikernel, those who are familiar with it, it's kind of an open source project which allows a lot of different programming languages to run on top of it. And it supports an OCI compliant runtime called runsc. So we had kata runtime, runsc, and runsc, right? And this is this new architecture for isolation. Now, pretty much it was a very interesting approach, on the security perspective, super secure and very, very tight control. I didn't find any breakout or any vulnerability. But again, keep in mind that operational wise, it imposed a big challenge. We'll talk about it more in the operational aspects of the different technologies, because you cannot use any image or any container. You can really use only the base allowed images which were written for this Solo 5 libOS or this specific unikernel. So although there's the onprem project, which make it a bit more easier, again, in essence, you need to have only approved images or base images, and the variety is very limited and it's very small. And also, you will see the support for Kubernetes is limited, although it exists. So it is a very secure approach, but creates a lot of operational challenges. Now, the interesting research which IBM did when they released the Nabla Container was very nice, was to create a new benchmark to test the security strengths of different projects. In this case, they created a benchmark called horizontal attack profile. It's trying to quantify what is the potential attack surface. Obviously, the lower attack surface, the better. And they measure how many system calls are possible. They multiply by the amount of code which is written. As you can see, they tested, different base images or base containers, and there was no surprise that Nabla came out to be the best. But in essence, it's a very interesting way to create a benchmark for security and trying to understand which has more potential attacks. Now, the last son in this family, or the last member to the family, was introduced somewhere end of November, beginning of December, during the Amazon AWS reInvent. And during reInvent, AWS released the Firecracker. Okay, and the Firecracker is a very interesting thing. It's a micro VM. It's a micro VM which is used for, I would say, ephemeral execution. So it's used for the AWS Fargate, which is a container as a service, or the Lambda function, which is a serverless function in AWS. And they run the Lambda or they run the Fargate in this secure environment. It will be a little bit more challenging to run long-lasting tasks in this environment. I'll explain in a minute why. So they're using it for Fargate and for serverless container or serverless functions. It's an optimized virtualization environment, so it's an optimized hypervisor, lightweight micro VM, super optimized on the performance side, around 100 milliseconds startup time, 125, something like that, and super optimized from the security perspective because they stripped out from this KVM environment any device driver or any driver or any piece of code which is not needed for the purpose of executing those VMs or running those containers inside, which, by the way, was one thing that was not removed in the QEMU, or only partially removed in QEMU. And that's why in QEMU you can probably find some more vulnerabilities. Here at AWS took really care and really minimize the amount of code or the amount of available resources. So what you can see over here is, again, you have the KVM as a baseline hypervisor. You have a micro VM. In each micro VM, you run the container. So just like in a very similar way to Katacontainer, they support containerd as a runtime to manage or run the micro VMs using, again, similar architecture, using a shim to intercept the runtime commands and to link the containerd with a micro VM, and they have an agent inside each VM which intercept those runC commands. Now, an interesting thing is that they do not support it's not an OCI compliant runtime, so you won't be able to execute it in a regular Kubernetes cluster environment. You can't execute it in a different or expect it to do any of the different runtime commands. Only the very limited set of commands, which again put it in a different space when we're talking about the operational of the Katacontainers. Now, I apologize for this noise. I forgot to turn off my email. Now, when you look at the security aspects, of Firecracker, so it started. So Firecracker pretty much started from Chromium OS. Okay, it's written in a Rust, which is a big plus for the security perspective. Okay, it's minimized the VMM, okay, based on the Linux KVM, so it's only support for emulated devices, so the code base is, of course, very limited. But as I said before, the main challenge of the Firecracker, not the security, because the security side seems to be very thoughtful or taken care of. The main challenge is the operational aspect. Operational aspect, how you can run and execute it in real time or in real, production Kubernetes environment. And let's go into more the operational perspective and examine those technology, the operation aspects of those technologies to try to get a more broader picture. So after we cover the architecture, the security, let's go into the different operation aspects. So when you're talking about, I try to create some kind of, look at different aspects of operations, right? Let's talk about the ease of use, for example. So we'll talk about the installation, how do you install and run the different runtimes. So Kata and gVisor are very simple and intuitive. Nabla, slightly more complex. Firecracker, even more challenging. So, but again, probably due to the maturity of the different environments and how long they've been on the road, probably it's going to be improved as we progress. Now, going to different runtime itself, so Kata and gVisor and Nabla, they all support OCI compatible runtime. So, it's very easy. You can see right here, this is, the Katacontainers, all the different commands used from Docker are supported. And the same on gVisor, the run SC, that you can see all the different options and commands. Not all, but most of them are supported, so it's very easy to run and use those environments. In Nabla Container, the run NC slightly more limited, and again, probably due to the maturity level. But again, only very short commands are supported. And in Firecracker on the other side, none of this is supported, right? So you can really, it's much harder to run or to Kata and gVisor provide a very good user experience to run containers. Nabla from the feed only approved base images. There's only limited variety of those images, only limited options in your run. You need to write very special URL. It really make the usage of Nabla, I would say, not intuitive in production environment for running multiple clusters, running with Kubernetes or any type of orchestration. It could be a little bit more challenging using this environment. Talking about performance, so pretty much all different sandboxing technology has some performance penalty. Now, those of you who are interested, there is a great piece of work in Openstack. Openstack made a very nice benchmark between Katacontainers and gVisor, looking at different executions of different containers and different scenarios and environments. They're trying to make a very nice benchmarking process, very detailed report. You can see it in this link. I also gathered all the resources that they used for this talk at the end of my slide. So those of you going to be interested in find out more background information or links to some information at the end. But when you look about, the different technology, it's probably, Firecracker has the best performance, okay, the fastest boot time and pretty much negligible overhead. Kata and gVisor, since they're using kind of different emulations, they have some higher performance penalty, some kind of an I/O performance penalty of 15-20%. When you look about the CPU, the memory overhead is relatively very small. Boot time is higher than Firecracker, something between 500 milliseconds to 700 milliseconds, which is not so bad. So this is related to the general statistics. Given the fact that at least Nabla and gVisor are using some user space networking stacks, this is definitely has a penalty. So this definitely reduced performance. But overall, I think the basic assumption is when using sandboxing technology that you don't implement it on your entire environment. You're probably going to select those applications or those containers which you really want to protect or has the biggest potential for attack, and those which you can, of course, tolerate this performance penalty or overhead, and probably on the rest, you will just keep them running regularly there. And this brings the next aspect of coexistence, right? How coexistence. So the first basic need is I was checking if who supports or right. Supporting any type of orchestration like Kubernetes is really essential. Probably it's going to be not practical if not. So Kata supports Kubernetes and it really works very, very well. It uses experimental in gVisor. I think they advance and it's in a more stable version. Nabla claims to support Kubernetes to some extent, but if you keep in mind that their 1C runtime is only early phase version 0.2, the scope of the supported Kubernetes is still limited. And Firecracker as is does not support Kubernetes or container or CRI or runtime. But an interesting thing that was just released lately was Katacontainer did a nice work together with Firecracker and they allow to run their agent inside the Firecracker micro VM. And if you're using the latest Kubernetes version of 1.13, you'll be able to use Katacontainers together with Firecracker and create your secure environment which supports Kubernetes. And this is something which has a significant potential to get the very good security with the good operation maturity level of Katacontainer, a very nice option to use. Now, another interesting topic is that all sandboxing runtimes can coexist on the same host. Okay, so there's no exclusivity. You can run a few containers with Kata or with gVisor and can run the others just regularly as they are. And again, as I said before, it allows you to really mix and match or integrate or use both technologies simultaneously. So we can use different sandboxing technology. You can run also regular containers on the same host, and this is something which make it very flexible. So if I want to wrap up and summarize the things which we discussed and talk about, so containers, attacks, and I would say probably the new vulnerabilities which we discover lately all are on a rise. Sandboxing is a great method to minimize the attack radius. Still, keep in mind that it's better to prevent attacks, to avoid or minimize the attack vectors, or try to remove or minimize the potential of the attack, not just to minimize the radius after the attack happened. Of course, it's important, but it's also important to look at a holistic perspective and try to cover all the different angles. We saw 4 different sandboxing technologies that were using 3 different architectures, whether it's virtualization in some way or another, a user space kernel or unikernel. Until now, there's no like a real knockout alternative when you're considering security, operation, and performance. Probably as those technologies will mature and get more in use, you will see probably one which will shine above another. And the important thing is, as I said, good container security need to address a lot more dimensions than just preventing the radius. It's just part of it. It does not replace it. And an interesting quote that I saw from Jessie Frizzell, who's known for a lot of container security aspect, is that really, when it comes to the bottom line, when she was analyzing the gVisor technology, she said, that a good security require more than one layer of security is required. You really need to get, I would say, more holistic approach to your security. So that's all on the container sandboxing after today. You can have some more resources or references here. So if you want to get more details on the different environments or the different technologies, or get the GitHub projects, all this, or benchmark, performance benchmark, everything is available over here. And I'll be glad to answer any questions or address any issues that you might have. Thank you very much.
Thank you, Ariel. That was really useful. I've been working with security a little bit, so definitely answered some questions for me. We have a couple of questions on the chat. Why don't we start with that? And I'm hoping some more will come. Is Katacontainer supported for on-prem and cloud? Is Katacontainer supported for on-prem and cloud-based Kubernetes installation? If yes, then can you just tell us where to look for it?
Okay, so right, the answer is yes. You can deploy Katacontainers in both environments. Now, it's a little bit tricky because if you need, in order to deploy Katacontainers in the cloud, it's kind of you create a nested virtualization. So the tricky part is, yes, you can run it in the cloud, but you need a bare metal instances, which are a little bit expensive, but you can use, you can run it. So you just need to install the runtime and execute the runtime in your cloud environment or your on-prem. You can use it both.
Okay, that's interesting. So what you are saying is, if I'm running an AMI, then I probably cannot use Kata on top of AMI, or on EC2 instance or Google instance, or even hypervisor like VMware hypervisor. I can't really use Kata on top of that.
Yeah, you need an instance which supports nested virtualization. If you're running AWS, so the instance is, you can use, they have the the Metal series, which is a bare metal instance, and this is something you can use. I used it, I tested it in AWS and it worked fine. But it's still a little bit expensive, but yeah, but it can work fine.
Okay. Looking at your presentation, it sounded like most of the attack vectors in Kubernetes are related to Kubernetes settings. Is that accurate to say, or there are several factors outside of that? And I understand container isolation is one, but anything that is outside of Kubernetes core settings?
Oh, I definitely agree. I definitely agree, and I think that at least today, most of the attacks are related to settings. Some, like the API gateway vulnerability, doesn't relate to settings. This is vulnerability in the API gateway that allows you to take over full control of the cluster of the master. So this is not really related. But yes, again, most of the attacks we see today and most of the items we see today really relate to settings or improper settings. I fully agree with this statement.
Okay, that works. There were a couple of questions / requests for a demo. We don't have that much time left, so I don't think you have planned for a demo, Ariel. Is that correct?
Yes, I'm sorry. If I knew, I would prepare it, because the setting up it takes some time. If I knew, I would kind of already created a demo. We won't be able to make it in the time that's left. I'm sorry.
No worries. And guys, I have started a GKE cluster, and then from the GKE marketplace, I have acquired AquaSec, and then used it on my own for demo and learning and all that. If you are really interested, it's like a 5-minute job, and you can go and try it out, Aqua, at least, just from the perspective of getting to know what the capabilities are. You can do it online. I've done it, and it has worked for me, and it didn't take me more than like 10 minutes to set it all up. I do not think there are any other questions, Ariel, so we can so my apologies, there are questions, and let me just go through some of these. What would be a good approach for implementing containerization with layered security?
Okay, that's an interesting question, and I think well, I'll put it this way. When you're trying to create a layered security, you need to address multiple vectors. You need to address vectors like scanning capabilities, and maybe even starting your CI/CD. You need to address runtime that prevent or at least protect you from different things. And again, you need to prevent, or you need to at least to protect not just the container itself, but also its underlying infrastructure, which is the host and the operating system. So you probably would like to create kind of an automated process of automated, controls that follow the container lifecycle and the execution time, and making sure that the relevant aspects are covered. So when it takes an image, it's only image which was approved, and only image which doesn't have vulnerability. It's a known and approved, not something unknown, right? When you're running, making sure that it doesn't have like root or privileges. So there are certain checks and balance checks, I would say, that you can run automated in your process, and making sure that you always improve your security level. And keep in mind that it's slightly different between in different stages. You probably need to follow different steps in a different part of your environment. So this is kind of in a nutshell, probably requires some more deeper explanation, but I would say this is in the highlights. How would I create a layered security for containerized environment?
Yeah, it's interesting because when I think about the similar thing, I think of it as two ways. You can have horizontal layers or you can have vertical layers, and vertical layers go all the way from your hardware and bare metal up to the app. And that includes your hypervisor layer, that includes your Kubernetes components, containers, of course, which are your workloads, and network. So you can go at every layer and you can try to secure every layer. And then the second way to look at it is that horizontally from the build time, your image security, your Kubernetes security, and then your runtime security. So like basically do it horizontally across the CI/CD pipeline. So I think that's an interesting question to ask as well. Like when you call it layered security, what does it mean? Like which way to go?
Right, I definitely agree. It's a nice analysis. The horizontal way, and also the sideways. Definitely, it's an interesting way to look at it.
Okay, another question. Is there an equivalent of OWASP best practices for container security?
Oh, nice. Not that I'm aware of, mainly because the ops is kind of more on the application level, looking at different, application potential vulnerabilities and attacks. While usually, the containers, Kubernetes, so there's more on the infrastructure itself. There is a CIS benchmark for Kubernetes. There is also CIS benchmark for other environments or other flavors of Kubernetes that allow you to get best practices. And this is what I know today as the benchmark a lot of people use to verify the security level.
Okay. There's a question which is interesting for probably both of us. Could you differentiate between what Kubernetes provides versus Aquasec versus Rancher? Like basically, the gentleman is trying to figure out what can I do with core Kubernetes, and then why do I need tools like Rancher and Aquasec? Maybe I can take first crack at it, Ariel, and then you can come in and add more details. So,
Okay.
so just to let you know, Kubernetes itself provides a bunch of security settings. You can go and do a search. There are about 100 plus settings that you can do on Kubernetes to secure everything. For example, data at rest, data in transit, how you connect to your API server, whether it's HTTP or HTTPS. Do you have privileged containers? Can you allow running containers as root? Like all these various settings that you can do just in Kubernetes. The problem is it's really, really complex. It's really, really hard. If you're comfortable, go ahead and do it. If not, then what you can do is use a tool like Aquasec. Aquasec, by the way, is not the only tool in the market, but they are pretty good. And what you can do is you can select you can define policies, create them once, and now these policies will be applied, Kubernetes policies will be applied at runtime. And then what Rancher does is Rancher actually helps you in building Kubernetes clusters. You can build multiple Kubernetes clusters using Rancher. And then with a one single UI, single pane of glass, you can manage all of these different Kubernetes clusters. You can enable things like monitoring, auditing, logging with one click. If you have an app that you want to deploy to multiple clusters or multiple namespaces or projects within a cluster, you can just do a one push button and it gets deployed to all of them. So all these things come with Rancher. And then from security perspective, Rancher at the time of the building your cluster, Rancher can also help you set up Kubernetes settings through Rancher UI, so that you don't have to deal with a whole lot of individual Kubernetes settings on your own. So that's Rancher versus Kubernetes. And then my take on Aqua is that Aqua provides much more things where you can set policies, you can do sort of a test of your clusters and figure out which settings are fine, which are not. You can use industry benchmarks like CIS and set up your Kubernetes accordingly. You can run security scans on your images. You can run image scanning. Multiple other things. Go ahead, Ariel. You probably want to add more on Aqua.
Right. I just said a little bit, about it. I think and I fully agree with everything you said. And I think maybe the Aqua can on top of protect you from the unknown. So if someone is trying, by some way found even vulnerability indication, which is not by Kubernetes, which more looking for the underlying infrastructure and manage to run kind of a crypto mining inside. So this is where Aqua can come and making sure that no one is running different executables, or no one in doing any extensions or using some unknown or not allowed things which maybe leverage legitimate tools. Things like what was discovered last week, this new runcy vulnerability that Kubernetes doesn't see. And it's not even up to Kubernetes even to see this already, but if using Aqua, our runtime will kind of help you to figure out there is a vulnerability and prevent any execution or any exploitation of this vulnerability. So I would say that pretty much Aqua can add this layer of the unknown or the things which might happen using legitimate things, but being exploited to do unlegitimate activities during the runtime environment. This is the thing that usually the classical, role-based access control, all the different settings, I just don't see, and this is something that Aqua can discover and protect and prevent.
Okay. What role does Aqua play in container sandboxing?
Okay, so that's a very good point. And what we do together with the different sandboxing technologies is we're trying to complement it. So we aim to provide an holistic container security, and then using also sandboxing as part of it. So you can run a container sandboxing, run Aqua inside your container, so to protect you from all the other aspects that are required, and get an holistic solution together. So we don't compete with sandboxing. We encourage people to use sandboxing, and we know how to run inside those sandbox environment and complete or complement those aspects which are not addressed by container sandboxing.
Okay, thank you. So it's past 11, and I see we still have a number of attendees, around 100 and quite a few actually. I don't see that many different questions on the board. Just for everybody to know, yes, this is being recorded, and yes, it will be available to you after the session is over. You will get an email with a link, and you can always come to our training page to kind of get more information. Let me just bring up a couple of links for you. So all people who are asking for all these questions about is it supported and all that, maybe those will be answered. Let me see. Meanwhile, I'll ask another question of you. Does AquaSec has open source tools to use? Ariel? Okay, I'm not sure if we lost Ariel, but I will ask. I'll answer quickly. Yes, they do. They actually have some of the tools like KubeBench. I think that was one of the AquaSec projects that they started. And what KubeBench does is it checks your Kubernetes clusters against CIS benchmarks. It's free. It's open source. You can go and try it out and see what other open source projects they participate in. So and I don't know if the question is about their core offering, which I'm not sure if it is open source or not. I don't think it is.
No, it's an open source, but we have few tools, like you said, the QBench. We also released about a few months ago a very helpful doing pen testing these clusters. You just give it, credentials and just go on all the different nodes, all different elements, and test and try to find if there's any hole, vulnerability, or any open ports or anything might put you in a threat. It's an open source tool. You're more than welcome to use it. And it's, again, so we contribute a lot to the community. A lot of open source which released. There's the KubeHunt, KubeBench, a lot of Kubernetes tools that, and we keep developing more and more tools for the community to use.
Nice, thank you. I keep getting questions about what is Rancher. So guys, I'm going to take just 2 minutes to talk about it. Basically, Rancher helps you helps you manage your Kubernetes clusters. So you can provision a new Kubernetes cluster. You can provision many of those on any infrastructure of your choice: AWS, Google Cloud, Azure, DigitalOcean. You can actually build EKS, GKE clusters. And then we provide a number of tools for your monitoring, for your logging, for your auditing. We just added a support for a new capability, which is called multi-cluster application. So you take an application, you point it to multiple clusters. One may be on AWS, another one may be on Google Cloud, third one may be on vSphere, and you click one button, and the same application gets deployed everywhere. So we have a number of capabilities like that, which anybody who's dealing with enterprise grade Kubernetes, or they are just trying out Kubernetes for their dev test and their production, you will find it extremely useful. So you can have rolling upgrades of your apps, all these nice things. That's what we basically do. It's completely open source. It's completely free to use. And unlike other container management as a service platforms, we don't have an enterprise version versus an open source version. Everything is a community edition. So you can go and try it out today without having to pay a dime. You can scale as much as you want. You can use it in your production, whatever you want to do. We don't limit usage. If you want to get started, the easiest thing is to go to www.rancher.com and then follow links from there. It's much easier rather than probably remembering this link that I'm showing right now. But we have a quick start guide, and the installation takes like 5 minutes, and I've done it myself multiple times now, and let me tell you, the first time it took me about 7 to 8 minutes. It's really, really simple if you have the basic understanding of how containers work. If you have worked with containers a few times, then you should be able to deploy and use Rancher very quickly. You can try us out on github.com/Rancher. We have a very strong community. We have millions, probably 100 million plus downloads, thousands, tens of thousands of users, thousands of enterprises worldwide who use Rancher. So you can come to forums.rancher.com. You can follow us on our blog. We actually are very active. We write something new almost every week, every other week. We have a very hyperactive slack.rancher.io channel, very helpful. So if you're starting out, asking questions, getting lost, come to slack.rancher.io, and you will find a lot of good people willing to help you out just from the community. If you're just starting out on Kubernetes and you're wondering like, hey, I've tried it, but I don't fully understand it. Can I get started again? Then yeah, there are tons of tutorials online. You can do it. And then every Thursday, we'll run a live training, rancher.com/training. You can go sign up, and some very experienced individuals will come, and they will start at a very basic level of what Kubernetes is and how to build a Kubernetes cluster, how to get started, how to deploy your first workload. So they cover a lot of good things, and they use Rancher as well. So you can see how easy it is with that. And that's it. That's all I have to cover. More questions coming in. Ariel, if you're okay, then we can take 5 more minutes, try to answer all of these, or if you're running out of time, then we can stop.
I'm okay. I'm still here.
Okay, so there is an interesting one. Basically, the gentleman is trying to ask what is the difference between Aquasec and Falco, and if I'm sure you know, Falco is Sysdig's open source.
Right. Okay. So it's a good point, and I must admit that I'm not so much familiar with it. I didn't dig into it. I saw a demo of Falco in KubeCon. There was a session about it, so I was curious to hear about it. And I think that pretty much, if it's come to me, that I might say, that in AquaSec, what we try to do is try to give you an holistic security, and we start we're looking at the full lifetime, or the entire, I would say, maybe probably more correct, so the entire lifetime of your container. So we start in the CI/CD with the images and the different scanning. We also scan your registries to make sure that nothing is changed or new one people not discovered. And we also monitor your runtime, your actual runtime when you're running. And I think this is pretty much where we have some overlap with Falco. Now, we added a lot of controls on the runtime, so it can really protect and prevent any potential attacks to the host, to the container, to the operating system. So we're trying to give a lot. I think we're giving more coverage to more potential attacks. As far as I recall, in the Falco, and it could be that I'm mistaken, so I apologize in advance, but my Falco is really intercepting the different messages and trying or creating some kind of a policies based on those commands. But for example, if I would try to run an exploit or a malware or any kind of a executables which run on them in your container, which probably attempt to be legitimate or follow a legitimate procedure, would be probably hard to detect or to stop it using in this way. It's more kind of getting a monitoring environment. But again, I admit that I'm not super familiar with their solution.
Okay, I'll ask one last question and then we can wrap up. And the question is the cost for Aqua. I know your cost through GKE Marketplace, but you may want to, I don't know if you want to address that or not.
I didn't hear the question. You were disconnected. Maybe you can repeat it, please.
Yeah, the gentleman wants to know the cost of Aqua.
Oh, okay. I think probably the best will be to approach us, and just pretty much the cost is based on the amount of nodes which we are using, and that's pretty much,
Yeah.
I would say that's right. Again,
And
it varies based on the environment.
Sorry, yeah, I've used on GKE, like I said, and there were 3 layers for Aqua. You can start with the basic, small node for about 5 cents per hour, and you can go all the way up to 33 cents per hour, and that's just GKE Marketplace. It's public, so you guys can go check it out yourself. But I think if you're asking for something more substantial on-prem, all those things, then as Ariel said, please follow them at aquasec.com and try it out. Same with Rancher. I think I'm getting questions about Rancher support contracts and pricing. So please follow us on rancher.com and reach out to us. Someone will definitely get back to you. But just to get started, Rancher is free to use. So it's open source and it's free to use. All right. Thank you, everybody. I think we will wrap up. Thank you very much, Ariel. Thank you, everybody, for joining. I think it may be pretty late for some of you, and thanks for staying with us to the end. Bye-bye.
Bye-bye.